Hi, John McPhail here from Matex Control Chemical in Calgary, Alberta, Canada. I want to speak to you about one of our products that we call Hole Control. Hole Control has been specifically manufactured for your blast hole operations. What we're looking at here is we're speeding up our hole collaring, reducing collar sloughing and stabilizing the borehole itself. In this animation here, just to give you a little explanation as to what we're doing. If we're drilling without hole control, when we're drilling down, especially into a pre-fractured formation, either fractured from a blast or what have you, if you already had some holes drilled in this pattern, you can see we're losing our air, we're communicating over the other holes. Sometimes we're backfilling these holes, and when we're doing that, we're not getting the air to drive our cuttings out. You can see they're starting to hang up here, and sometimes if you turn your air off, those cuttings drop, and boom, you're stuck. If we can introduce hole control right out of the gate, you can see it's coming down here. We're pasting with the fines, we're making a paste and we're packing the fractures. So we're stopped the communication, we're no longer backfilling. All of your cuttings are just blowing right out of that hole. So if we can make the inside of this hole look like the inside of a rifle, you can imagine what's happening with your penetration and everything else. Everything is just shooting right out of that hole. I have a couple of videos here that I want to show you from actual footage in the field.
Area of the pit here that's got groundwater standing in these holes at about 10 feet. You can see the nice neat collar. The hole is a real precise diameter, 6 3/4 down through the sub drill, place where they've always had problems here before. The texture of the cuttings is totally different. They're a lot coarser. I don't know if the tape is showing you how encapsulated the fines are with the bigger cuttings. If you ran this through a sieve mesh, you'd find that you had an average larger size of the cuttings here. These holes are probably being drilled a little quicker, a little more efficiently. We've increased the viscosity of the baling medium, therefore it's lifting a lot of these cuttings out. Cleaner and neater, giving you a bonding effect. We're literally gluing this stuff together. What we've got here are the sample sacks from the last 2 holes drilled. These are the cuttings from the first hole using the standard water injection. This was D2 Drill-Tech rubber tire D40K 6 3/4 inch hole. You can see the fineness of the cuttings, how that bit has to regrind them to fit them with the available baling capabilities of the compressor. And this is the second hole. You can see there's quite a difference as far as mesh size of the cuttings. The encapsulation is very obvious there.
Okay, that video was a few years ago in the US. I have another one here in New Zealand, and I want you to watch and listen for the exact similarities as to what our end users are telling us about these products.
This is a good hole. He's coiled it up properly, and we work the hole control more into the walls of the hole, so we follow the crevices, the weakness until the product gets as far as it can, and it's come back through the wall of the hole itself, and now we've got a good casing around the hole now, and that'll be, as you can see, it's very supportive. Normally we'd put cones in, but in a situation like this where it's been left for the weather, the hole, as you can see, is still held up to the elements, so it's certainly got its advantage.
And it's been hanging around for 3 weeks, yeah, just like this.
And this is what we've pulled out of the hole. That's the size.
And that's larger than you normally.
Oh, yeah. Well, that's the other thing too. It's reducing the wear and tear on your.
Another good video from the field, and you can see that hole has been standing around for about 3 weeks. So this product is really gluing the cuttings together and allowing the holes to stay open. Another issue these days is silica dust. You can see drilling without hole control and drilling with hole control. The encapsulations of the fines is magic. If you look at this hole that's been drilled using hole control, this is a little deeper hole. We had the opportunity to send a camera down there, but look at how symmetrical this hole is with hole control and without hole control. You can imagine filling this hole full of explosives versus this hole, and then after the blast, the fragmentation that you're going to get from a nice symmetrical hole. Again, back to collaring, you can imagine how much time it would take to collar this versus this, and the expense to put in your tubes in these holes. This is another quick video. I just want to again show you, if we can collar this hole right out of the gate where we're not working it, we're turning that time into production drilling time instead of trying to collar the hole. And it's pasting the fines together, making a nice little ball like you've seen in the previous videos. It's magic. How do we get this product in there? With the Matex fluid injector. There's more information on our website about this fluid injector, and all of our videos are on the website. When you have the fluid injector hooked up and you're injecting the product in there, every time you make a connection, either out of the drill pipe or out of the top quill, you'll see a couple of stringers hanging down there. What you're going to want is anywhere between an 8-inch and 10-inch stringer hanging out of your drill pipe. That way you know you've got the right amount of product going in there for your hole size that you're drilling, and it's going to glue your cuttings together, just like you'd seen in the previous videos. There is our website for more information on our injector or any of our other products. I hope this helps you with your blast hole operations. Thank you for watching.